Hello dear students, this is your engineering mathematics 3 lecture. In last lecture we had started second unit and the concept of the topic in second unit, first topic Fourier transform. Now the next example, new example is here. Find the Fourier integral representation of f of x is equal to, the function is defined into intervals, is equal to 1 when mod x is less than or equal to 1, and it is equal to 0, then mod x is greater than 1. Hence, evaluate the integration of 0 to infinity sin lambda cos lambda x upon lambda into d lambda, and integration of 0 to infinity sin lambda upon lambda d lambda. Okay. Now, the solution for this example. Find the Fourier integral representation means you find the inverse Fourier transform for the given function. Now, to find the inverse Fourier transform, first you to find the inverse Fourier transform, first we have to find out the Fourier transform, because to find the inverse Fourier transform, we require Fourier transform. Now, to find the Fourier transform, you first check whether it is even function or odd function. Now, here in this function f of x, if we replace that x by minus x, then the function is here, it is equal to 1 when your mod of minus x is less than or equal to 1. It is 0 when mod of minus x is greater than 1. So if we replace x by minus x, the function here, the condition that variable is inside the modulus sign. So there is no change in the function. If we replace that x by minus x, we are getting the same function. And if this is the situation, then in that case, that function is even function. The best example of even function is cos function. In cos function, if we replace x by minus x, means cos of minus x is again cos function, cos x. So if we replace x by minus x and we are getting the same function, then that type of function is even function. So here the same case, if we replace x by minus x, we are getting the same function. So f of x is an even function of x here. Okay. So you find the Fourier cosine transform. If function is even, then in that case we find cosine transform. F suffix c is for cosine transform, and the formula to find the cosine transform is integration of 0 to infinity f of u cos lambda u du. Now, what is the function f of u? Actually, our function here, it is in terms of x. The variable x is here to define the function. You just replace that x by u, then you will get f of u. It is equal to, it is defined in two intervals. And one is the point of discontinuity, and the limits for a cosine transform is here 0 to infinity. So one is the point of discontinuity. So integration will split in 0 to 1 and then 1 to infinity. Now in between 0 to 1, when x is less than or equal to 1, the function value is 1. So replace f of u by 1 into cos function as it is cos lambda u du plus. Now from 1 to infinity means when x is greater than 1 and up to infinity, then the function is 0. So second integral 0. Now 1 into cos lambda u, integration was 0 to 1 cos lambda u du. Integrate cos function. Integration of cos function is sin lambda u upon lambda, because variable is here u and constant is here lambda. Integration of cos function is cos sin lambda u upon lambda, and the limit 0 to 1. Now upper limit is 1. So here variable is u. So replace that u by 1. So sin lambda upon lambda minus, if we put lower limit 0, sin 0 is 0. So the second term is 0. So the cosine transform is here only sin lambda upon lambda. Okay. Now here we want the Fourier integral representation. Means we want the inverse Fourier transform, but the function is even. So you find the inverse Fourier cosine transform, and the formula is here. F of x is equal to 2 upon pi into integration of 0 to infinity fc lambda into cos lambda x d lambda. This is the formula of inverse Fourier cosine transform. In first lecture of Fourier transform, we have discussed the results, the concept of Fourier transform. There were discussed about the formula of cosine transform also. Okay. So here fc lambda, f suffix c. Now what is fc lambda here? Its value is here in this example. The value of fc lambda is here sin lambda upon lambda. So put fc lambda is equal to sin lambda upon lambda into cos lambda x d lambda as it is. Okay. And in the formula, the constant term is there 2 upon 5. Okay. Now you find the value of this integration means you transfer this term 2 upon pi in LHS. If we transfer it here in LHS, it will be pi by 2 into f of x. Where we just rearrange the term and we have this new term integration over 0 to infinity sin lambda into cos lambda x upon lambda d lambda is equal to pi by 2 into f of x. Rearrange the term here. The previous term, we will get this new term here. Okay. Now, our aim is find the inverse Fourier transform. Inverse Fourier transform means find the Fourier integral representation of. So this is the Fourier integral representation of the given function. This is integration of Fourier integral representation of the function and the value of the term integration of 0 to infinity sin lambda into cos lambda x upon lambda d lambda is pi by 2 into f of x. F of x is the given function. Okay. There is one deduction also that and hence evaluate integration over 0 to infinity sin lambda upon lambda d lambda. Now, in this integral, we want to remove this cos function. If we remove this cos function, then we have the value of the integral integration over 0 to infinity sin lambda upon lambda. Now, how to remove that cos function here in this result? How to remove this cos function? If its value is 1, then we have the value of this integration of 0 to infinity sin lambda upon lambda. Now, how to make the value of cos function 1? Now, variable is here lambda because integration is with respect to lambda. So, we cannot change the variable lambda. The constant term is here x, cos lambda x. X is constant. So, if we put x is equal to 0, then the function, this function will be cos 0 if x is 0. You know cos 0 is 1. So, if we put x is equal to 0, cos function is 1, cos 0, its value is 1. So, the integration of 0 to infinity sin lambda upon lambda into d lambda is equal to pi by 2 into. Now, what is function? What is f of 0? So, when x is equal to 0, function is defined here in two intervals when x is less than or equal to 1. Now 0 is less than or equal to 1 and so the function value is 1 here. Okay. But in this integration, the function value is pi by 2 into f of x. Now the function value when x is equal to 0 is 1. This 1 into this pi by 2 means the final answer is pi by 2. Because the value of the integration is not only f of x, it is equal to pi by 2 into f of x. And when x is equal to 0, f of 0 is 1. When x is 0, the value of function is 1. And so 1 into pi by 2 is pi by 2. So answer is pi by 2. So this is the solution for first example. Find the Fourier integral representation means you find the inverse Fourier transform and then you will get its Fourier integral representation. That is the meaning. Okay. Now next example is using Fourier integral representation. Show that integration was 0 to infinity 1 minus cos lambda pi upon lambda into sin lambda x d lambda is equal to, we define in two intervals pi by 2 when x is in between 0 to pi. It is 0 when x is greater than pi. Now using Fourier integral representation, the same thing here, you find the inverse Fourier transform.